So guys, we as already discussed, we are now about to discuss how to derive the maximum torque and maximum mechanical power developed in two conditions. That is when all parameters are considered. That is this case two, and only rotor parameters are considered as given in this one. In this case one. So according to case 1, as I was telling, only when rotor parameters are considered and stator parameters are neglected. That means what are the parameters given in the question now? R2 is the parameter given and X2 is the parameter given. Only these two. According to second, we are telling that all parameters are considered. What are the all parameters that can be given in the question? He will give you the R1, X1, and he may give you the XM and R2 and then X2. So all these parameters like this. Okay. So now we will see the case 1 only when rotor parameters are considered. So basically getting into this topic now, see, I will just redraw the two circuit diagrams back again. That is only rotor parameters as I'm telling. So when neglect the stator and just draw the rotor circuit, and this is how the rotor circuit looks. And there are two ways of representing this rotor circuit just because of this fellow, this resistance component, because this is the total resistance component in the first diagram. You can split this back into two components, that is ohmic component as given R2 and the mechanical component of load, okay, or electrical component of mechanical load as given over here. And it is a variable quantity because it depends on the load, and this is what your load basically is. So one way of deriving the value of the condition for maximum torque developed in any or in this particular induction machine, as you have seen in the textbooks, is differentiate the torque equation with respect to slip and equate it to 0, because at maximum value the differentiation of any equation will be 0, and you can find out what is the value of slip where you will get the maximum torque developed condition. So this is one way, this is one mathematical way, and you are well aware about that. I am not going to discuss that. I am going to discuss a much easier and appealing way to derive this formula, this condition. That is by using maximum power transfer theorem from circuit analysis. What does maximum power transfer theorem help us in doing? Basically, maximum power transfer theorem helps you if you are having a load connected in a circuit, at what value of load resistance or load impedance you will get the maximum power into that load, isn't it? Suppose you are having a load resistance, and if your entire network is resistive in nature, if your RL, that is your load resistance, equals to source resistance, then you will get the maximum power transfer. Now next case is if your load is resistive but your circuit is both resistive as well as reactive in nature, that is when you have impedance in the source, then if your load resistance is equal to the impedance magnitude of the source, then you will be having the maximum power transfer. That is, this is the value of source impedance. Suppose if your load as well as your source both are impedance, then if your load impedance equals to the source impedance ka conjugate, then you'll be having maximum power transfer. So I hope you are clear with these things. So now I am having two circuits like this. Now which circuit should I use in order to apply the maximum power transfer theorem? Now you see the first circuit. In the first circuit, what is the load? R2 by S, which is nothing but the total resistance. In the second circuit, what is the load in the circuit? Wherever there is a variable part of resistance, that becomes your load in any circuit. This electrical component of mechanical load is the load here. And now we are interested in finding two parameters, that is maximum torque. The other one is maximum mechanical power developed, isn't it? What is the maximum mechanical power developed? So where does mechanical power basically correspond to? It corresponds to the mechanical load. In this both diagrams, which diagram is giving you separately mentioning about the mechanical load? This one, isn't it? So I can say if maximum power is transferred to this load, this resistive load, this resistance load is nothing but it is a mechanical, electrical equivalent of mechanical load. This is nothing but it is like atma of mechanical load. So if I say if maximum power is transferred to this fellow, automatically maximum mechanical power is developed, isn't it? And mechanical power, next maximum torque. If this diagram is considered, if maximum power is transferred to R2 by S resistance, then I can say maximum torque is developed in that particular machine. How come is it true? Suppose you are, you know, what is the total power given to the rotor, or I can say it is equal to the air gap power, isn't it? Total power in the rotor is nothing but the air gap power. The total air gap power is transferred to the rotor. So air gap power is equal to 3 times I square into R2 by S, isn't it? Where R2 by S is the total resistance or total load in the rotor. It includes the rotor's copper loss component as well as the mechanical component applied on the rotor. Okay, so if I want to find out what is the torque developed, the torque developed in any induction motor is equal to, just divide this power equation by omega s, isn't it? Now you see torque is directly proportional to the total resistance component. That means this, my what I'm telling is justified. What I'm telling basically, in order to derive the condition for maximum torque developed, you have to consider R2 by S as load in your equivalent circuit diagram, and then find, just proceed. Then what is the formula for mechanical power developed in general? Mechanical power developed formula is this one, right? 3 into I2 square into R2 into 1 by S minus 1. That means if maximum power is transferred to R2 into 1 minus S minus 1, then you will get maximum mechanical power developed, isn't it? Understood? Now I hope you got clarity which diagram to use for which, finding out which quantity. Now see, I want to find out what is the maximum power, maximum torque developed. So again, another thing I want to make clear, what does maximum torque developed in the rotor means? Maximum power transferred to the rotor from the stator, then you will get maximum torque developed in the rotor, isn't it? I am finding out what is the condition where I will get maximum power into this R2 by S. What is R2 by S corresponds to? R2 by S is nothing but it is the, it corresponds to the power given to the rotor, air gap power, isn't it? So if you're see, and also we have already seen while deriving torque equation that Tg was proportional to E2 into I2 into cos phi 2, isn't it? Power transfer to the rotor. If power transfer to the rotor is maximum, automatically torque developed is also maximum, isn't it? So I just want to find out what is the maximum power transfer to the rotor from the stator, then it is automatically equal to maximum torque developed in the rotor. Now you see here your load is resistance, but your circuit is having some impedance component. So RL will be equal to magnitude of the impedance. That is nothing but, what is your RL? R2 by S equals to X2, and you got the condition where you will get maximum mechanical maximum torque developed, the slip for maximum torque developed, that is R2 by X2, and you know, you are very well aware about this equation. And what is the rotor speed at this condition? That is rotor speed at maximum torque developed condition, that is ns into 1 minus s mt. And maximum mechanical power developed at this I mean the mechanical power developed under this condition is 1 minus smt into pg. Understood? So this is when you are considering only rotor parameters, neglecting the stator parameters. Now let us see the other case. What is the other case? Now all parameters are considered, all stator plus rotor parameters are given. So all stator rotor parameters given in the question means, what are those parameters? R1, X1, Xm, and on the rotor side R2 and X2. If all these parameters are available, then you can use this technique. Now I will just redraw the diagram considering the stator parameters as well. So this is the stator side. Now on the rotor side we are here. This is R2 by S, this is X2, this is Xm, this is R1, this is X1, isn't it? Now this is the equivalent circuit considering all the stator parameters as well. Now let us say this point A and B. Okay, this is A and B. I just want to replace this circuit with a Thevenin equivalent. Because of this presence of this shunt component, this shunt element, my analysis is going to become a little lengthy, because finding value of resistances or impedances which are in series is much easier than having some parallel components, isn't it? You agree with that? So I just want to replace this parallel component with series, equivalent series one. So I just, what I will do is I will just disconnect the rotor from this side, okay, from AB, and I will apply Thevenin's theorem to this particular circuit. Thevenin theorem. So what does Thevenin theorem say? Suppose you are having a number of voltage source, different type of resistance, and the circuit is looking complex, then you can replace the entire circuit with just one bloody single voltage source in parallel with some Thevenin impedance, series impedance, in series with some impedance with some series impedance. So this is the equivalent to Thevenin circuit, isn't it? It looks very simple, isn't it? So I just want to disconnect. So in order to apply Thevenin's theorem, you have to disconnect that part of the load which you don't want to disturb. So what I don't want to disturb is the rotor part, because the rotor part is entire, it is having only series components, it is having no problem. I'm not having any problem with the rotor side, but I'm having problem only with the stator side. So I will apply the Thevenin's theorem from AB terminals. Now I will find out what is ZTH. Now the ZTH will be equal to what? It equal to XM parallel with R1 plus JX1, isn't it? Let us say this equals to some RTH plus JXTH. Okay, let us say this equals to this much, and I want to find out what is the Thevenin voltage. Okay, I am interested in finding out what is the Thevenin voltage. Now what will be the Thevenin voltage? Thevenin voltage is nothing but open circuit voltage at that point where you are replacing the circuit. So I want to find out what is the VAB, that will become your Thevenin voltage over here. So here VTH will be equal to nothing but VAB, and what is the VAB as per potential divider rule? I can find out V1 into XM by R1 plus J into X1 plus XM. So this is the Thevenin equivalent circuit. Understood? So just replace this entire circuit with Thevenin circuit. So if you replace the entire circuit with Thevenin circuit, then you will have a Thevenin voltage source as given like this, VTH, and you will have an RTH, then you have an XTH. So this is the Thevenin circuit that you have created. And what was the existing circuit that initially we removed? That is a rotor circuit, isn't it? Now this is the rotor circuit actually. R2 by S, this is X2, isn't it? Now to this circuit I am applying the maximum power transfer theorem in order to find out what is the maximum power transfer to the rotor, that is the rotor resistance component, isn't it? Now understood what I am telling? So my RL must be equal to the source impedance magnitude. So what is my RL? R2 by S. What is my total source impedance? Okay, source impedance is nothing but I can write down like this, isn't it? RTH whole square plus XTH plus X2 whole square, isn't it? From this equation I will derive what is the slip at maximum torque developed. The slip at maximum torque developed is equal to R2 by RTH whole square plus XTH plus X2 whole square. So you got the maximum slip developed condition when all stator and rotor parameters are also considered. Now there may be another case. The question may be asked, what is that another case? Is magnetizing branch is neglected in the stator. If again, what does this mean? Now the given parameters are x1 r1, x2 r2, that's it. Now the equation is very simple. If there was no xm, I need not apply any Thevenin theorem, isn't it? Then this x RTH is nothing but this would have been my R1, and this would have been my x1, and this VTH would have been my V1, and there was no this part missing, isn't it? So simply I will just modify this equation only. So if xm is neglected, then my slip at maximum torque developed will be equal to R2 by R1 square plus x1 plus x2 whole square. Understood? Very simple. Okay. Now you have to remember, this is when R1, x1, xm, R2 and x2 all are given, and this is when only R1, x1 and R2, x2 are given. And what is the value of SMT when only R2, x2 are given? R2 by x2. Only in the question when you find only R2 and x2. Understood? I hope you make a clear note of all these variations. Okay, and the corresponding rotor speed will be, as you know, rotor speed at maximum torque is nothing but this synchronous speed minus SMT. Understood? And you can find out what are the corresponding formulas. Just put the value of slip. Now, okay, everybody clear? Now the next parameter that I am interested in finding is maximum mechanical power developed in the rotor. What is the formula for maximum mechanical power developed? Actually 3 by omega s I2 square into R2 1 by s minus 1, isn't it? Okay, your maximum power transferred, your mechanical power is related to R2, this part R2 into 1 minus s minus 1, 1 by s minus 1, this part of the resistance. Okay, that means if this part of resistance, if you get maximum power to this resistance, then your mechanical power is developed is maximum, as we know. So just I will redraw the circuit with the stator parameters R1 X1. So basically now first we are actually interested in doing with only stator, only rotor parameters considered, isn't it? So let's say only rotor parameters are considered. So I will just draw only the rotor side diagram. Okay, so on the rotor side what will be having? So R2 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 into 1 by s minus 1. E2 is the voltage. Okay, I2 current. So in order to get maximum power to the load, that is R2 into 1 by s minus 1, the magnitude of load resistance must be equal to the source impedance magnitude. What is the source impedance magnitude? Tell me, what is the source impedance magnitude? That is nothing but R2 square plus X2 square, isn't it? From this I can find out what is the value of S. I will just simplify this. R2 by S minus R2 is equal to R2 plus X2 whole square. R2 by S, then this is the slip at maximum torque, is equal to R2 plus R2 square plus X2 square. The slip at maximum torque developed will be equal to R2 by R2 plus R2 square plus X2 square. Now did you get the point? Okay, this is the maximum mechanical power developed condition. Okay, I'm sorry, this is not SMT. This is the condition for maximum mechanical power developed. This is SMM, maximum mechanical power developed. And what was the maximum mechanical torque developed condition? It was simply R2 by X2. And what are these parameters? When only R2 and X2 are the only given parameters. So this is the condition. Okay, only R2 and X2 are given. Now you see how different both are them. Both of them are. Now next case is when stator plus rotor, that is R1 X1 XM R2 X2 all are considered. So if all are considered, then again your circuit will look like this: R1 X1 XM, and this is R2 X2, and electrical component of mechanical load of the rotor. This is our hero, R2 into 1 by S minus 1, R2 X2 XM X1 R1. Again the same story repeats over here. I will just replace this part of the circuit, the stator part of the circuit, with VTH and RTH. Then the circuit transforms like this. XTH, this is point A and B. and apply the maximum power transfer theorem, that is load equals to the source impedance. The source impedance equals to R2 plus RTH whole square plus x1 or xth plus x2 whole square under root, isn't it? So just simplifying this, I will get slip at maximum mechanical power developed equals to, okay, it equals to R2 by, okay, R2 by R2 plus RTH plus R2 whole square XTH plus X2 whole square. Okay, did you get the point? Again, if xm is neglected, in this also there is a different case. If xm is neglected, that is you are given only x1, r1, x2 and r2, just replace rth with r1, that's it, nothing more different. smm will be equals to r2 by r2 plus under root r1 plus r2 whole square plus x1 plus x2 whole square, that's it. So did you get how did we derive all these formulas? Yes. So what was the corresponding values of slip at the maximum mechanical power developed when only rotor parameters are considered? It was how much? R2 by R2 square plus X2 square, isn't it? This is when, okay, this is when only rotor parameters R2 and X2 are considered, and this is when all parameters R1 and X1, R2 and X2 except magnetizing branch is considered, and this is when R1, X1, XM and R2, X2 are considered. Okay, so make note of all these formulas and just keep them in your mind. And the corresponding rotor speed will be equals to rotor speed at maximum mechanical power developed is equal to synchronous speed 1 minus smm. Okay, smm. So this is the maximum or I can say the rotor speed at these conditions. And what is that value of maximum mechanical torque or maximum mechanical power? So that maximum mechanical power developed will be equal to 3 by omega s into I2 square into R2 1 minus SMM minus 1, isn't it? Is it right or not? Yes, it is right. So this is how you derive all these three formulas, or in total 6 formulas in different conditions. I hope you are well understood now and you're clear how to make the diagrams and all these things. Okay, now we will just see some relationship between the TST starting torque and T max and full load torque TFL, all these things. Okay, so before that we will find out what is the T max equation equals to. So assuming that only rotor side parameters are considered, T max occurs at when SMT is equal to R2 by X2, that is only rotor parameters are considered. Okay, stator parameters are neglected. Okay, that value of T max equals to, okay, that value of T max equals to 3 by omega s, the square of voltage divided by 2x2. This is the equation for T max, maximum torque developed. Okay, as you look at this equation, the maximum torque developed in any induction motor does not depend upon the rotor resistance, because there is no rotor resistance term. The maximum torque developed is proportional to 1 by x2 rotor reactance, but slip at which maximum torque occurs is directly proportional to R2, isn't it? Look at this equation. And slip at which maximum torque occurs is inversely proportional to reactance. Understood? As I was telling, E2 is nothing but the induced voltage in the rotor side will be proportional to the flux in the machine, and flux in the machine is proportional to the V by F ratio of the supply voltage V and supply frequency F. So from this equation T max, from T max I can tell it is proportional to E2 square, isn't it? And E2 will be proportional to flux square, and that will be proportional to V square by F square. Okay, so from this I can give this conclusion also, isn't it? That my T max will be proportional to square of the supply voltage, square of the supply voltage. That is, if I increase, so T max is proportional to square of the supply voltage. It's not just T max, all torques are proportional to the square of the supply voltage. All torques, just it's not just T max, all torques are proportional to the square of the supply voltage. That means if V1 is the supply voltage, V is the supply voltage, I can say if V is increased by or scaled by X times, okay, if the supply voltage V is modified by X times, then your torque will be modified by x squared times the original torque. Or if you are appearing for competitive exam, approximately the modification in torque will be 2x times. By this what I mean is, suppose if V2 is 2 times of V1, that is the voltage is doubled. Voltage is how much? Is doubled. Then what is the uh, I can say change in torque? What will be the T2? So according to this convection, if voltage is increased by how much times? 2 times, that will T2 will be equal to 2 times of x, that is 2, that is equal to 4. And anyhow, you know, if you put this in formula, 2 square into t, that is equal to 4 times of t, it is satisfied. Now you may say it is because it is equal to 2, then it is satisfied. Now let us see in different terms. Suppose if voltage, applied voltage is increased by 10%, is increased by 10%. That means what does V2 will be equal to? 1.1 times of V1, isn't it? So if V is increased by 10%, okay, according to this approximate convention, then torque will be increased by how much percent? 20%, is it not? Will be increased by 20% approximately. Now let us find out what is the actual value. Now what is the x here? X is 1.1 times, isn't it? So torque will be increased by how much? 1.1 whole square times the original torque, T2. What is 1.1 equal to? 1.21. 1.1 specifies increase of 21%. So I am getting approximately 20, and exactly it is 21% increase. Okay. So like this you can reduce your time of calculation. Okay. So just keep all these things in your mind. Okay. And other thing, so if T max was proportional to V square, I can also say T max was proportional to, okay, is proportional to V square by x2, isn't it? So V square by x2 into f square, isn't it? V square by f square, and x2 is proportional to automatically frequency. That means maximum torque is proportional to what? 1 by f cube. Maximum torque is proportional to 1 by f cube. Please keep this thing also in your mind. Okay, if the frequency increases, maximum torque will decrease. All right, so this is about maximum torque. And again, uh, let us look at this starting torque. So what is starting torque equals to? Starting torque equals to, starting torque is nothing but S is equal to 1 in the torque equation. That's it, everything is done, everything is gone. So S is equal to 1, 3 by omega S, and E2 square into R2 by S by R2 by S whole square plus X2 whole square. Just put S is equal to 1 and it is gone. So just put S is equal to 1 and it is over. So now slip is equal to 1. Slip is equal to 1 at the time of starting. Which type of region? Is it high slip region or low slip region? It is high slip region. In high slip region, I already told you that torque is inversely proportional to the slip. That is, R2 by S is there and you have X2. Both are in whole squares only. If slip is more, R2 by S will be less. In square, it will be much more lesser. That means I can neglect R2 by S, isn't it? That means only term will be there present is x2. So I will just neglect this one. So approximated TST formula will be equal to 3 by omega S into E2 square by R2 by S by only x2 square. Okay, only it is x2 square, isn't it? Okay, so this is the value of starting torque as by s will be cancelled out, okay, because it is equal to 1, s will be equal to 1. So from this relation, you know, starting torque is proportional to square of the voltage, isn't it? And it will be inversely proportional to the square of the frequency. Starting torque is proportional to 1 by x to square. From, if I combine these both, I can tell starting torque will be proportional to f to the power of 4, isn't it? This is also one condition. Okay, and if you think uh, full load torque, TFL, torque at full load condition. At full load condition, what will be the value of torque? T by E, that is nothing but 3 by omega S, again E2 square into R2 by slip at full load by R2 by slip at full load whole square plus X2 whole square. At full load condition means, what does it specify? At full load condition means what will be the condition? NR will be less. If NR will be less, slip will be high, isn't it? So here also you can approximate in the same way and you will get the same conditions. Okay, so SFL represents the full load torque condition. Next thing is, I want to take the ratio of starting torque to T max. If I take the ratio of starting torque to T max after approximations, let us say the slip at maximum torque as MT will be equal to A, and normal slip will be equal to same S only. At the time of starting, the slip will be equal to 1. Then this formula will be equal to 2A by, okay, A square plus 1. If I want to take the ratio of TFL by T max, this will be equal to 2AS by A square plus S square. Okay, where S is nothing but the slip at full load, or I can say at any load. Basically, slip at full load specifies nothing but slip at any load. I hope now you are clear with all the slip, okay, power, torque, all these parameters are clear now, I guess. So once you are clear with all these parameters in the induction motor, then you are king of the induction motors. Thanks for patiently watching.